Hey there. We're about to dive into geometry, but I want you to forget about dusty textbooks and boring math lessons. We're going to look at it for what it really is, a secret toolkit for understanding and even shaping the world all around us.
You know that feeling, right? You're standing in a room trying to figure out if that new couch is actually going to fit, or you're staring at a wall just guessing how many cans of paint to buy. It's so frustrating. But the solution is way simpler than you think, and yeah, it all comes down to geometry.
So I want you to think of this as our own little workshop. We're not just going to memorize formulas. We're going to craft a real practical toolkit that'll help you solve these kinds of puzzles and a whole lot more.
All right, let's get to it. Every good toolkit needs the basics, you know? The hammer, the screwdriver, the reliable stuff you'll use over and over. For us, that means getting a handle on the formulas for the most common shapes we bump into every day.
First up, the good old rectangle. I mean, they're everywhere. Doors, windows, your phone screen. The perimeter is just the distance all the way around the outside, and the area is all the space it covers inside. Super simple, really elegant, and incredibly useful.
And this shows it perfectly. Let's say you have a rectangle that's 8 units long and 3 units wide. Maybe it's a small garden plot. Well, the area it covers is a nice, clean 24 square units. That's all there is to it. Length times width. Done.
Next in the toolbox is the square. And really, a square is just a rectangle's super-organized cousin, where all the sides are exactly the same length. And that makes the math even easier. The area is just the side length times itself.
And what's cool is that this rule works no matter the size. Even for a super tiny square with a side of just 0.04 units, the formula works like a charm. We get this tiny little area of 0.0016. The logic is always the same.
Okay, what about triangles? We're going to start with the right triangle, mostly because its area is so easy to figure out. If you think about it, it's literally just half of a rectangle, sliced in two. So you just multiply the two sides that make that perfect corner, the base and the height, and then just chop it in half.
So, for a right triangle with a base of 5 and a height of 12, its area is exactly 30. And get this, here's a fun little coincidence with this particular triangle. Its perimeter, so adding up all the sides, is also 30. Just a neat little quirk.
Okay, so we've got our basic tools down. Now let's get a little clever. Let's learn to use them like a detective, by starting with a clue and working backward to find the missing piece of the puzzle.
So, let me throw a puzzle at you. You know the total length of fencing for a square pen is 20 centimeters. But how in the world do you figure out the amount of space inside that pen with just that one number?
We work backward. The clue we have is the perimeter, 20. Now, since we know a square has 4 equal sides, we can just divide 20 by 4. That gives us the missing piece. Each side has to be 5 centimeters long. And from there, the rest is easy. We solved the final puzzle. The area is 5 squared, which is 25. See? We just thought in reverse.
All right, you ready for a real power-up? We're about to add algebra to our toolkit. Now, hey, don't let that word scare you off. It's not some new complicated set of rules. It's really just a shortcut that makes the tools we already have way more powerful.
And this slide right here shows you why it's not scary. On the left, a simple rectangle with numbers. Easy. On the right, we've got letters. But here's the secret. It represents the exact same idea. Just think of algebra as a code for numbers. It lets one formula solve an endless number of problems.
So, let's try to crack one of these codes. We have a parallelogram, which is kind of like a slanted rectangle. Its base is 2x and its height is y. The key to the code is simple. X equals 5 and y equals 4. So, what's the area?
Well, it's as simple as just plugging in the numbers. The base, 2x, becomes 2 times 5, which, of course, is 10. The height, y, is 4. And since the area is just base times height, we do 10 times 4, and we get 40. See? Algebra is just a puzzle, and we just solved it.
Okay, we've gathered our tools. We've even upgraded them with some cool algebraic shortcuts. And now for the best part. Let's put this entire toolkit to the test on a real-world challenge.
Okay, picture this. You've got 26 feet of fencing. You're building a pen for your rabbit, and you're going to use the garage as one of the walls, so you only need to build 3 sides. The big question is, what dimensions should you make the pen to give your rabbit the absolute most space to hop around?
Well, let's test a couple of ideas. We could make the long side against the garage 12 feet long. That would leave us 7 feet for each of the 2 shorter sides, giving us an area of 84 square feet. Okay, or we could make it 10 feet long, which would mean the other sides are 8 feet each.
But that only gives us 80 square feet of space.
So, the 12x7 pen is clearly the better of these two options, no question. But here it is, the key question that our geometric toolkit helps us answer. Is it the absolute best option, or is there some hidden combination that gives that rabbit even more room?
And it turns out there is. For this kind of three-sided pen, you get the most area when the long side is exactly double the length of the short sides. By using our tools, we find the perfect dimensions. The side along the garage should be 13 feet, and the two sides coming off of it should each be 6.5 feet. That gives us a maximum area of 84.5 square feet. That right there is optimization in action.
And that, right there, is the whole takeaway. Our toolkit, the formulas, thinking in reverse, the algebra. It isn't just for passing a math test. It's a real-world guide for making smarter, more efficient decisions about all sorts of things.
So now I'm turning the question over to you. Whether you're rearranging your living room, planting a garden, or maybe even building a rabbit pen, you have the tools now. So what puzzle out there are you going to solve?